Hey guys, so let's discuss new round, which is round 3 of Amazon, and which is the coding round 2. Let's say you have given a question which is called design an LFU cache. Okay, so LFU is list frequently used. Okay, let's say you have a doubly linked list and you are adding nodes there. Okay, in that doubly linked list, and then when you do get or put, right? So let's say this is 1 2 and 3, so I have run the function like put 1, okay, then put 2, and then put 3. So how many times you have accessed these elements? See, one, this node you have accessed once only, so frequency is 1 right now. For this 2 again 1, this 3 again 3, 1. Okay, now if I run some operation like get 2, so it means that I'm touching this node second time, right, for the get operation. So now the frequency will become 2 for this second node, right, and then frequency is 1 for them, and for this still it is 1. Again, if I do get 3, let's say, so in this case the frequency will be 2 for this 3, because second time I'm touching this node, right, and then let's say the capacity is 3 only. Okay, and then when I run again new function put 4, so capacity means already the linked list length is equivalent to capacity. So in that case you have to delete one element, and then only you will able to insert new node, right? So which one you will delete? So you will delete least frequently used, so whose frequency is lesser. So right now this second node frequency is 2, third node frequency is 2, but you can see this one is 1, so you will delete this 3 1, and then you will add this 4 here, and then its frequency will be 1, right? So this is the least frequently used, and I have already explained you least recently used also in data structure, so you can go and check that. So for now we will be working on least frequently used this thing, okay, cache. So it means that whenever you have a cache, okay, and it is the capacity is full for that cache, so which element you will remove? You will remove whose frequency is lesser. Okay, nobody is reading that, nobody is using that much, so you can delete that one, right? So now see, this one is the one of the most common Amazon, Google, Microsoft coding question, because it tests your data structure, your object or oriented design, and then your time complexity, production thinking, and scalability. Okay, so like rate limiter, just before this video we have seen rate limiter, right? Coding round 1 was related to rate limiter. So the interviewer expect your answer to evolve based on your level. Your level means, you know, that we will be talking about here 3 levels. The first one is software engineer, second one is senior software engineer, third one is architect. Software engineer could be SG1, SG2. Okay, now, okay, so what software engineer is expected to answer here? So he should give the correct order 1 implementation. Okay, we'll see Java code here. Then senior software engineer, so he should add, so apart from this implementation, he should be able to add, or he should be able to talk about thread safety. What if you're running it in multi concurrent environment, right? So in real time it is concurrent environment only. Then production readiness and time to leave and monitoring. Now if he is a principal architect, in that case he will be talking about distributed cache. Okay, because your system is distributed, you have a multiple server, and in each server you have a cache. Okay, so cache cluster you also have, so distributed cache consistency, multi-region, and failure handling. Okay, so in multiple region your application is deployed to multiple region, and how you will handle that. So now let's see what software engineer usually have 3 to 6 years of experience, what he would be answering. Senior software engineer would be around you can say 7 to 12 years of experience, and on above that it's a principal architect or architect. Okay, principal software engineer or architect. So now software engineer would say that before implementing the cache, I would clarify few requirements. Okay, so like for example, he will be asking questions like what is the cache capacity? That is the first thing. Okay, then only you will remove the element, right, on based on the capacity. And then second is what should happen when capacity is reached, and is the cache in memory or distributed. Okay, and then means single server or multiple server. Then is thread safety required, means are you running it in a concurrent environment, or are TTL expiration needed. Okay, So for an LFU cache, the least frequently used items evicted. Okay, this is what we have seen, and if multiple items have the same frequency, I would evict the least recently used among them. Let's say node second and node third frequencies 2 and 2. Okay, now you have to delete one element. So which one you will delete? Least recently used. Okay, not the current one, not the recent one, the least recent one you will delete. So now so what will be the approach here? Okay, so see, you will have a two hash map. Okay, so in one hash map you will have a key and node, and in second hash map you have a frequency as a key and value as a doubly linked list. Okay, and then you will track minimum frequency, one variable which will track your minimum frequency, so that you don't need to traverse entire doubly linked list to just get the minimum frequency. So now here operations, which all operations you will be using, see, get. Okay, so whenever you are getting something, see, you have a one hash map, let's say. Okay, we will call it as cache hash map, because we are implementing here cache only, right? So whenever you're putting element, you will put into the cache hash map, right? Now when you are getting the value, you don't need to touch that cache hash map, right? Because you're not putting anything new in that, you're just reading value from there, but you will change its frequency. Earlier it was 1, now it will become 2, because you're using that node again, right? And then you will have second hash map. We will see that in a code. Okay, so there you will update, because that is a frequency map, right? So you will update the frequencies. Now so put will use as a insert and delete, and if full, remove least frequently used element. Okay, if it is full. Now Java code you will be seeing here. So you will have one node. Okay, so its structure would be key, value and frequency. So one node, it's a structure like, for example, put 1. So I will create one node. Okay, 1, and it's a frequency, so it's a first time it is 1. Then second, put 2, so it's a frequency is 1, something like this. So this is the node structure. Okay, now in then you have one doubly linked list class. Okay, and in doubly linked list definitely you will have a head. This is your, let's say this is your doubly linked list. Okay, so you will have one head, you will have one tail. Okay, so one head, one tail. Initially node 0000 it is pointing. Okay, and then you would be having few functions here, like add in a doubly linked list, add node in a doubly linked list. So you just adjust the pointers. Okay, then remove from doubly linked list and remove last. Why remove last? Because you will be storing in this linked list, okay, frequency wise, like for example, if we will see that. Okay, so whatever is not frequently used, you will put that in a last in a linked list. Okay, and then we will delete that. So remove last will do that, and then is empty will check whether the linked list is empty or not, doubly linked list. And then this is the main class LFU cache. Okay, so now here see what is happening. We have one variable which is called capacity. Okay, and then one minimum frequency. See, node frequency is different and this minimum frequency is different. Okay, so initially minimum frequency will be 1. Now I told you we will be creating two maps. Okay, so this is first map, this is second map. So first map will be cache map, normal cache map. Okay, you are adding your nodes there, so it will be integer comma node. Okay, and node structure we have already seen. Now the doubly then frequency map you will be having. Second map would be the frequency map, which will be something like this. Key will be integer and value will be doubly linked list. Okay, now you will be initializing capacity in a constructor, and then see, this is your normal get function. So whenever you have two maps. Okay, one you are using for to maintaining your cache, all the node value will go there. Okay, and then second will be the frequency map. So you will be adding there like which node is coming how many times. Okay, so whenever you're getting value, you will not touch cache map, right? Because you're not changing its structure, right? So see, in get what will happen, first you will check that whether cache contains that key or not. If it is not containing, then we can't get it, right? So just return -1. Otherwise just get the value from that cache. Okay, get that value from node. And so let's say you have this 1, 2 and this 3. Okay, this is doubly linked list, so double links. Now you are getting 1, so get 1. Okay, so this is your doubly linked list. Okay, this is your cache, let's say this is your cache, and then you're doing get 1. So get 1 will give you this node. Okay, and then you will pass this get node to update function. Now what is happening in this update, and just return the node dot value. So like 1 you will return, so get 1 will be the value, it will return its equivalent value. Now the main thing is what is happening in the update function. So let's jump onto that update function first. Okay, so this is your update function, and see what is happening here. Okay, first whatever node you're passing, okay, you have passed node 1 here, so it will get its a frequency, old frequency. Okay, now you're doing get operation on that, so frequency will increment, right? Frequency will change. So what you will do, first from frequency map you will get that element. Okay, so frequency map something like this, that the key will be integer. Okay, so first time 1 is coming once only. Okay, so for frequency 1, when the key is 1, so for that linked list would be something like this, 1, 2 and 3. Why? Because every node's frequency is 1 initially. Okay, now you have done get 1, so in that case you will delete, now it's a frequency became 2, right? So you will delete it from this frequency 1 linked list, and then you will create one new node, frequency 2, and then you will add 1 there, right? So that is what we are doing in update. Okay, so you are getting that frequency map list. Okay, so for example this list you have taken, and then you will remove the node. So like this 1 you are passing, so it will remove this 1 from this list. And after that what you are doing, currently your frequency is equal to minimum frequency. This is the case when or list is empty. This is the case when you have nothing in the list, right? You have deleted everything. Then in that case you will update your min frequency, right? Right now mean frequency is 1 only, because for this is 1, for this is 1. Okay, now so now node frequency plus plus, so now node frequency will become 2, right? So this 1 was here, and then now its frequency will become 2, and you will frequency become 2, and then frequency map dot compute if absent. Okay, currently it is not there in this map, we have deleted it, so it will create a new doubly linked list node. Okay, and it will add here, so it will add this 1 here, okay, at the end, and after that it will add that 1 there in this frequency map 2. So here node dot frequency, so node frequency became 2, so it will add 1 here. Okay, not there, not in the frequency 1 map, but here. So this is the get function. Okay, order 1 complexity. Now what is happening in put? If you are putting new value in a cache, right? So in cache you will add that value, and also from frequency map you will update its frequency also, right? If it is already there. So what is happening in put? Let's say this is your put function. Okay, this is your put function. So now what you're doing? See, you're passing your key and value. Okay, new node. Let's say 4 came, right? So 4 was not there. So it will check if capacity equal to 0. No, capacity right now it is 3. Okay, and we have used all 3 capacity. So now in this case you have to remove least frequently used element. Okay, and then from the cache, and then you will make a space, and then you will put this node there, right? So if cache dot contains this key, in that case what means, this key is already there in the map. Okay, 4 was already there, so right now that is not the case, but if it is already there, right? So anyways you're touching that node again, right? So you have to increase its frequency again. So in that case just get that node, okay, check its value, and then again run the update function. What update function was doing? It was deleting value from cache, and then again adding new node in the cache with the updated frequency. Okay, right now we don't need it now because we don't have this 4 in our cache. Okay, this is the new one. Now it will check that cache size equal to capacity. Yeah, that is correct, because cache size is 3 and our capacity was also 3, right? So you will make a room for this node. So what you will do, you will get the minimum frequency, whatever minimum frequency you have in frequency map, and you will remove it. Okay, so from frequency map you have removed it, and then you will remove it from the cache as well. Right, after removing it you have created a space there, right? So you will just create a new node, and then you put that new node into the cache, and of course you have to add that again in the frequency map. Okay, so if it is absent, then first time it is came, right? So the frequency will be always 1, and then you will create a new doubly linked list and add that add that node in a doubly linked list. Okay, and then again your minimum frequency will become 1, because this is the first time it is coming, and minimum frequency would be 1 for this. So this was the implementation. Okay, here get and put both complexity will be order 1. So that's it. This was the program. Okay, now what senior software engineer is expected to answer for this. He should know all this implementation. Architects should also know all this implementation, but apart from that, they will again put some extra value, okay, extra answer. So like expected answer for senior software engineer would be the in-memory implementation works well within single JVM. In production, additional consideration included concurrency and then expiration, observability, and memory management. You have to keep track on all these factors also, right? Metrics also, like concurrency, expiration, okay. Because you are putting entry in a cache, so you need to give some eviction policy there also, otherwise your cache will become full and you will have no space in cache, right? And then observability, and after that memory management. So now production improvement, what he will do extra is he will use concurrent HashMap and instead of HashMap, okay. And then protect update to the frequency list with appropriate synchronized or logs, okay. He will add this synchronization or log there in a update function, because multiple threads will try to access this update function, right? And then add TTL support to stale entries expired automatically, and then collect metrics such as hit ratio, miss ratio, eviction count, and latency, okay. These metrics he will be talking about. And then size of the cache based on available memory and workloads, okay. It's not like any random value you will be giving. Available memory and workload, you will just decide the cache size. So principal software engineer would be answering for this, that at large scale an LFU cache is usually part of distributed caching layer, okay. The focus shift from in-memory algorithm to consistency, scalability, resiliency, and operational efficiency. Now, what will be the architecture? Architecture will look something like this. Client request will go to first load balancer. From there, it will go to your application, okay. And then after that, you will it will go to distributed cache, okay. And then from distributed cache, if it is cache miss, then go to database, otherwise it will return from cache itself if it is cache hit. So now key consideration here would be cache partitioning, okay, or sharding. So you can use cache partitioning or sharding here. Replication or failover, okay, just create a replica of a cache. If one goes down, you can use another. Consistent hashing, okay. After that, I've explained all these things in my system design videos. Please go there and check. Now cross region strategy, monitoring and alerting, cache invalidation, cost versus hit ratio. Now let's talk about some follow-up questions. We have around 10 or 11 follow-up questions, okay. So the first follow-up question will be difference between LFU and LRU. So let's see what is the difference. See, LFU least frequently used is remove least frequently used item, and LRU remove least recently used item, okay. So now it will track access count, how many time the element is frequently used, right? Access count, how many times user has accessed that element. And here tracks recent access, okay, who have used which element recently. Now this one is better for frequently accessed data, and this one is better when recent access predicts future use, right? So now software engineer will answer for this is LFU favors items that are accessed frequently over time, while LRU favors items accessed most recently. Okay, LFU is useful for workloads with a stable access pattern, whereas LRU adapts quickly to changing access pattern. Recently used, whoever used recently, it will change the that access pattern. Okay. Now LFU is based when the same data stays popular for a long time because it keeps the most frequently used item in the cache, okay, which is popular. It will keep only that element. And then LRU is better when the user behavior changes often because it keeps recently accessed item, quickly removes old ones. So let's say right now IPL score was trending, so it will keep least recently used IPL score, and after that Olympic score, after IPL Olympic started, so Olympic score is now recently used, so it will keep that only. Okay, it doesn't matter that yesterday for IPL 10 million people have accessed it, so it will keep that. No, which one is least recently used, it will keep only that LRU. Okay, now senior software engineer, what he will be answering that I would choose LRU for general purpose application cache because it's simply simple and adopts well changing and workloads. LFU is more appropriate when a small set of item remains consistently hot. Okay, now architect will see that the choice depends on access pattern. Okay, he will say depends on access pattern. Many production system even combine recently and frequency through hybrid policies. He will use both. Okay, and to achieve better hit rates. So the question was that which one you will use, LFU or LRU. So now follow up second would be why you have used a doubly linked list here. Okay, so since see, software engineer will say that a doubly linked list is allowed order one insertion and deletion when we already have a reference to the node. Order one insertion deletion, right? Otherwise you have to again order n for the traversing, and then you will find the element. Here you can go in both direction, right? Senior software engineer will say that each frequency bucket maintains its own doubly linked list, so we can efficiently remove the least recently used item within that frequency. That is what we are using in frequency map, right? Architect would say that doubly linked list minimize update cost, okay, and is a key reason for overall algorithm achieve order one operations. That's why. See, now the follow up third, see in doubly linked list, if it is a singly linked list, you have to remove one element, okay? So you have to traverse again to that element, and then you will adjust the links. Here you can go to both direction and then just change the links using previous and next pointers, right? So now follow up third will be order one implementation. So software engineer will say that we achieve order one by combining key to node map, frequency to doubly linked list. That is what we have did, right? And then minimum frequency tracker. Senior software engineer will say for this is every operation performs only constant time hash lookup and linked list update. No sorting or linear scans are required. Okay, so now architect will say that maintaining the minimum frequency explicitly avoids searching across frequency bucket during eviction. Okay, so he will maintain minimum frequency explicitly, right? Now follow up 8 would be related to thread safety. So software engineer will say about thread safety is I would replace HashMap to concurrent HashMap and synchronized update that modify linked list. Okay, concurrent HashMap and synchronized update. Now what senior software engineer will say for this is I would use fine-grained locking around frequency bucket to reduce contention instead of synchronizing the entire cache. So he will not synchronize entire cache. He will be using synchronization, okay, for that particular block only. So now architect will say that for high throughput, I would favor lock stripping or partition cache, so different keys can be updated concurrently with minimum contention. So he will not use synchronization. Okay, he will be going with lock stripping or partition cache. Okay, so just lock the partition of a cache so that other cache can be used by the users. Now follow fifth will be TTL support. So now time to leave. Okay, you need to give time to leave for each entries in a cache, correct? That after how much time it will get expired. So now software engineer will say each cache entry can store an expiration timestamp. Okay, during get expired entries are removed to buffer returning a value. So when you are doing get, that time only just remove the entry, okay, if it is expired. Then senior software engineer will say that instead of checking all cache entries continuously, you will use lazy expiration and background cleanup thread. Okay, so now what will happen in lazy expiration, remove expired data only when someone tries to read it, means get at the time of get only, right? If it is expired, like get one, but one is already expired, so you just remove that. Second one is background cleanup thread. Okay, you will run one background cleanup thread and then it will clean the cache. Periodically scan and delete expired entries that nobody is reading. So now this keeps memory clean without showing down every request. Okay, now architect will say that TTL policies should be configurable by data type and expiration matrix. Okay, data type and expiration matrix, so should be monitored to understand cache effectiveness. See, for each entry there should not be a same TTL value, right? So for example, for product catalog, the TTL value should be 1 hour, but user session should be 30 minutes, right? And stock price 5 seconds. You cannot keep stock price 1 minute, right? The value will change. Feature flag 10 minutes. So this thing. So the data type and expiration matrix. Okay, you will just configure different things. Now also monitor, apart from this, he will also monitor cache hit rate, then the number of expired keys, memory usage, and cleanup frequency. Now these metrics help determine whether the cache is effective or whether TTL values need adjustment. The follow-up sixth question will be related to distributed cache. Okay, how this your solution will work in a distributed cache, how you will manage it. Okay, so see, software engineer will say instead of keeping the cache inside one application, I would store it in distributed caches such as Redis. So inside a Redis, he will use it. Now, senior software engineer will say I would shard the cache across multiple Redis nodes using consistent hashing to distribute load evenly. So software engineer said that he will not keep that session in one session server. Okay, he will keep it in a cache, so every server, okay, will use it globally. Now instead of one copy of that cache, you just sharded it. Okay, let's say the cache is very big, the size is very big, so you will shard that and then place it in a different server. You will create a replica of it. Okay, just create a cache cluster, and then after that just use that, so that the traffic will be managed. Okay, and other things also like failover and everything you will manage there. Now architect, what he will say, so he will say I would design a replication, failover, rebalancing, regional deployment while considering consistent requirement and latency, right? So this is what I was saying, replication and then failover, the bigger scale things. Okay, large scale things. Now follow-up 7 will be cache warm-up. So now cache warm-up means you have already preloaded cache. Okay, so that you will not face that cache cold startup time. Okay, so now cache warm-up means loading frequently used data into the cache before user requests it, so the first user don't experience slow responses. So software engineer will say preload frequently access data during application startup. Senior software engineer will say that warm the cache using historical access pattern. Okay, now I have said you that you will preload the data, but on what basis? Okay, how do you know that which data we need to preload? So it's based on the historical access pattern. Okay, yesterday what user has watched, so those things recently watched. So like scheduled background jobs to avoid cold start latency. Instead of guessing what to preload, okay, analyze yesterday's most accessed data, use log and analytics to identify hot data, and then run a background job every morning after deployment to populate the cache. This avoids the cold start problem. Okay, cold start means empty cache causing many database hits. So the cache will be empty, so everybody will hit database, right? So that will it will resolve that problem. Now architect will say that for large platform, I would continuously warm hotkeys after deployment and failover to maintain a high cache hit ratio. After deployment, it will get restarted, right? So he will keep that, he will preload all those things. In a very large system, Amazon, Netflix, etc., whenever a deployment happens or a new server starts or Redis is started, okay, and then starts or a failure occurs, okay, the cache may become empty. Instead of waiting for millions of users to rebuild it, the platform automatically reload the hottest data, so the cache hit rate stays high and the database is not overwhelmed. So follow-up 8th is related to eviction strategies. You have multiple eviction strategies, okay, like LFU, LRU, FIFO, or random, okay. First in, first out, least recently used, least frequently used. So software engineer will say about those common strategies. But now senior software engineer will say the eviction strategy should match workload characteristics. Okay, how data, how request, how the request type you have, what is the workload? Okay, how many requests you are getting. For example, LRU is effective for temporal locality. Now what is temporal locality? We will see that. While LFU works well with consistently hot data. Okay, so temporal locality means that if data was used recently, it's likely to be used again soon, right? First time you're checking it, then definitely you have bought one share, let's say, okay, Must-Gone Doc you have bought. So definitely until you have that share in your portfolio, you will check that again and again, okay? So that is the temporal locality. And then LRU takes advantage of this by keeping recently accessed items in the cache and removing the one that have not been used for the longest time. Now what architect will answer for this is in production, eviction policies should be validated with workload matrix. He's saying again the same thing, okay? He's correlating this eviction policy with the workload matrix. The best policy depends on the actual access pattern rather than theory. Follow-up 9 will be related to cache stampede. Okay, so software engineer will say a cache stampede occur when many requests simultaneously try to rebuild the same expired cache entry, overwhelming the database. So you are getting lots of requests to database, okay, because cache miss happen, okay, for all the requests. Now senior software engineer will say that I would use pre-key locking. Okay, pre-key locking means one request is accessing database, so just wait for the other request will wait for that. Okay, so pre-key locking or request coalescing. Request coalescing means let's say instead of one by one sending the request, you will send in a batch. Okay, say a similar kind of request will combine in a group and then will send that. So that is request coalescing. So on the one request refreshes the data while other wait or receive the existing value. So the request coalescing, multiple simultaneous requests for the same data are combined into a single backend request, reducing duplicate work and improving performance. Now what architect will say for this? Okay, architect will say for this cache stampede, to mitigate stampede at scale, I would combine techniques such as request coalescing, stale while revalidated. Okay, you're revalidating it, so just show the old data, stale data. Then jitter TTLs, okay, time to leave jitter TTLs, just add some delay in that. Okay, and background refreshes to protect the database during cache expiration. I have explained all these terms in my system design video, just go and watch that playlist. Okay, now stale with while in revalidation is serve stale cached data immediately while refreshing it in the background, reducing user latency and preventing cache misses. So now follow-up 10 will be related to memory optimization. Okay, so memory optimization means using cache memory efficiently. Okay, so it stores most useful data without wasting space. Okay, if you have a more space, you will be able to store more useful data, right? So that's why memory optimization is required, and software engineer will say store only the required field, remove expired entries promptly, and choose an appropriate cache capacity. So here he is talking about cache capacity and then remove the expired entries. Okay, now what senior software engineer will say that I would monitor, see he will use the monitor term. Okay, he will monitor the matrix. I would monitor object sizes, okay, then tune capacity based on hit ratio and avoid unnecessary metadata that increases memory usage. So go beyond storing less data, so he will monitor how much memory each object is using, adjust cache size based on the cache hit ratio, and then avoid storing unnecessary metadata, extra information that waste memory. So for example, if every cache object contains 200 byte of metadata but only 50 byte of useful data, most of the memory is wasted, right? If the object is 200 but useful data is 50, 150, why to store that 150 extra information which is not getting used, right? So now principal engineer will say that at platform scale, memory optimization includes compact key value serialization. He will use the compaction algorithm there, and then efficient metadata structure, compression for larger values. Okay, he will use compression algos also there. Then memory usage dashboard, eviction rate monitoring, and then capacity planning based on workload growth and balancing memory cost against cache hit ratio. So that's it. Thank you. Let's see round 4. Okay, which is I think related to system design in the next video. So thank you. Bye bye.